Welcome back guys to our fourth class, which is hierarchical network design and networking cables. In this class we will have two parts, part 1 and part 2. Under part 1 we will cover what is hierarchical network design, what are some of the advantages of hierarchical network design, and what are the layers of hierarchical network design, and the comparison between those hierarchical layers. So under part 2 we are going to look at some of the networking cables that are commonly used. Okay, so without any further ado, let us begin our class. So what is hierarchical network design? Hierarchical network design is a strategy or a concept of dividing a large enterprise network into smaller manageable parts called layers. Okay, and these layers are access, distribution, and the core layers. So hierarchical network design is a concept of dividing a whole large enterprise network into a smaller manageable parts or layers. So what are the advantages of this strategy? 1. There is a redundancy in a network. As discussed earlier in our classes, we said redundancy is a state in which there are many links in a network. Whenever one link is faulty or is down, the network will forward data, or the devices will forward data through the other redundant links, like this one. These are redundant links. So suppose this link is down, this layer 3 switch will forward data through the other link. Okay, and there is better network performance. Dividing network into manageable parts provides a high performing network. Okay, easy management and troubleshooting. It's very easy to manage network that is divided into layers or parts. We can assign one guy to manage the access layer, another guy to manage distribution layer, and a third guy to manage the core layer. So these are the hierarchical network layers. We will understand how they function in the coming topics, so don't worry about that one. Let's move to our next topic. Hierarchical network layers. There are 3 layers: access, distribution, and core layers. And here we'll start with access layer. This is where end devices are connecting to the network. It is in this layer that every device in network, in every user device, end devices will connect to the network. Okay, so if you have a computer, you will connect to a switch or Ethernet port, on the walls. You can use those, and that layer is called access layer. The switch provides connection. The switches at the access layer of the hierarchical network design, these switches are used to provide network access to end devices in a LAN environment. This is a LAN environment, this is another LAN environment, this is another LAN environment, this is another LAN environment. So these switches are used to provide network access to these end devices that are connected in a LAN environment. Okay, so the switches are responsible for providing network connectivity between the servers and the workstations. Suppose there was a server connected here, see, and this computer are the workstations. So this switch will provide connectivity between the server and this workstation. So you can upload or download files from this server. Okay, good. Then the switches are able to implement several switching technologies like VLANs, port security. Don't worry about this one, we'll look at them in the coming classes. So these switches must be able to implement the switching technologies. So you have to understand what is required in the access layer. First, this is where the end devices are connected and what device are being used to provide network access in the access layer. It's called layer 2 switch or just a switch like that. Okay, good. So let's move to the next layer, the distribution layer. The devices that are used at this layer is layer 3 switches, also known as multi-layered switches. From the previous classes, we said that layer 3 switches performs both switching and routing technologies. They act as both a router and a switch. So at the distribution layer, the devices that are operating at that layer are layer 3 switches. Okay, so this is the distribution layer. This is the distribution layer. Distribution layer connects the access layer and the core layer. Okay, these devices operating at the distribution layer of hierarchical network design are used to connect the core layer and the access layer devices to communicate. So it's the distribution layer that will connect the core layer devices and the access layer devices for communication. Okay, the devices are responsible for aggregating the traffic from access layer switches and sent to the core layer devices for routing. Layer 3 switches at the distribution layer aggregates traffic from layer 2 or access layer devices and send them to the core layer. Okay, it acts as a bridge between the access and the core layer. You have to understand that. Alright, they provide functionality of segmenting work groups or users and isolate any possible network problems. Those are the functions of distribution layer. So know the devices that are used in the distribution layer and the functions of distribution layer. Okay, so to the next layer, the core layer. The core layer is the backbone of the network, the main source, the backbone layer of the network. The devices that are used here are either routers or layer 3 switches. Okay, routers or layer 3 switches. We can use routers or layer 3 switches. Remember, layer 3 switches perform both as a router and a switch. So we can use a router and layer 3 switches. These devices act as a backbone of the network and are of high speed to provide faster packet forwarding to other devices. Okay, and these devices provides functionality of aggregating traffic from distribution layer. See, they provide functionality of aggregating traffic from distribution layer devices and are able to transfer a large amount of traffic very quickly because they're the backbone of the network. They are required for network to communicate or to function better. Okay, that's why there must be of high performance or of high speed to transfer large amount of traffic very quickly. So you have to understand the meaning of a core layer. It's the backbone of the network. Without a core layer, backbone is something that must be there. It's the foundation. Okay, so the devices that are used at the core layer are either a router or layer 3 switches or multi-layered switches. Okay, and the functions of core layer. Okay, so let's move to our next topic: comparison between these layers. Access layer, distribution layer, and core layer. We look at the difference between all the three layers. Okay, so the device that is used at the access layer is a layer 2 switch, but in distribution layer it is a layer 3 switch. In core layer, which is the backbone layer of the network, it's either a layer 3 switch or a router. Okay, so access layer provide connection to computers, printers, end user devices, you can name them. But at the distribution layer, it provides connection between access layer and the core layer. Okay, then in the core layer provide connection of the distribution layer and the one wide area network. Okay, or between two distribution layers. Okay, suppose another distribution layer was here, was above here I mean. Okay, like this. So the core layer will provide connection between two or more distribution layers or one. Okay, then how many links are used at the core layer? It's only one link. You take your computer, connect to a switch, it's only one cable. But at the distribution layer, as you can see, redundant links, as well as the core layer, as you can see, so many links. Okay, the technology that is used at the access layer here is like port security, VLAN. Okay, but at the distribution layer is access control list. Then coming to core layer, it's route summarization. Okay, considering the speed at the various layers, the speed at the access layer is fast, at the distribution layer is faster, then at the core layer is fastest. Okay, I hope you understand the differences. This table is very important because it summarizes whatever we have discussed earlier, considering this diagram. Okay, so let's see what we have next. Oh, this is part 2. Part 2 of our class, we are going to look at type of networking cables. A cable are just wires to transfer data in a network. They are just wire to transfer data in a network. The mostly used cables, are category cables, which is popularly known as cat cables, fiber optic cables, and coaxial cables. So let's start with category cables or cat cables. Cat cables uses electrical signals to send data. Data is first converted into binaries, which is zeros and ones that computer can understand. Then the zeros and ones are then converted to electrical signals to move through the wires. Okay, understand the conversion method. Then the cat cables contains 8 wires covered with a plastic. As you can see, they are twisted. Though there are 8 wires, they are twisted 4 pairs. Each pair contains 2 cables. Okay, 4 pairs, 8 cables. Okay, when we want to connect these CAT cables, we can use connectors like RJ45 or RJ11. Currently people are using RJ45 and we used it to connect our computers. Okay, RJ11 is an old technology. Few people use it, but it's still in use. Okay, there are several versions of CAT cables. We have CAT3, CAT5, CAT5E, then CAT6. Currently I'm using CAT5E. I hope some are using CAT6 or CAT5. CAT3 is way back. Few people use it. When we want to connect the cable or we want to crimp it and include RJ45 so that we can connect to our computers in a network, we can crimp it as a straight through cable or a crossover cable. In straight through cable, they are used to connect different devices. Like you can connect a computer to a switch to a router, computer to a router, things like that. A crossover are used to connect same devices. When you want to connect a computer to a computer, a switch to a switch, a router to a router, you can name them same devices. Then during crimping, we have to use this style. Okay, if it is if this one is RJ45 on this side, RJ45 on this side, we must ensure that the first cable in the alignment is white orange, or this which color is this? I'm not good at naming colors, but white orange. Then the next one is that orange, the same way as this point, 1 2 3 till 8. You have to include this until 8. Okay, until 8 to up to 8. But coming to crossover, we can connect like this way. If this one is 1, this one can be 2, this one can be 4, see, 6, this one can be 5, this one can be 7, then 8, or this one can be 8, then 7. Okay, that arrangement, same as this side. Okay, as you can see, it's crossing over, but the straight through, I mean straight line. Okay, I hope you understand that. Fiber optic cables. Fiber optic cables are used to transfer data in form of light. Data is first converted into binary, zeros and ones. Then the binary is converted into light. Then that light moves through the fiber optic cable. Okay, conversion mode of data. Data transfer is very fast. The transfer of data under fiber optic cables is very fast, faster than CAT cables or coaxial cables. Fiber optic cables can be of two modes, a single mode and multi-mode cables. In single mode, light travel in straight line, as you can see here. But in multi-mode, light travel in a zigzag. Single mode, there is high speed, okay, because straight line travel very fast. But in multi-mode, low speed because of the zigzag. It will have to cover a long distance of zigzagging, Then in single mode, it's of high cost. Good things comes with high prices. So I hope you understand what I mean. In multi-mode, there is low cost. Bad things comes with low prices. In single mode, it can cover up to 80 km, but in multi-mode, only 2 km plus. In single mode, there is less attenuation, but in multi-mode, there are more attenuation. Attenuation means loss of signals. So in single mode, there is less loss of signals because of this line. Light travels in a straight line, but unlike in multi-mode, that the light travels in zigzag, causing the loss of signals, bringing more attenuation. Okay, single mode is used to connect LAN, data center, but in multi-mode we can connect wide area network, metropolitan area network. Okay, so I hope you understand what fiber optic cables are, how data are transferred through those cables, the two modes, the differences. Okay, so our last type of cable, coaxial cable. It's made of copper. See, this conductor is made of copper. It's used to connect like TV connection, telephone cable connection, LAN cable connection. Those who are using decoder, when we are taking a cable from the antenna, aerial, we used to call it aerial, to your decoder, that cable is called coaxial cable. You have to understand. It's faster than cat but slower than fiber cable. See, there is a outer jacket, the braided shield, the foil shield, then the dielectric. This one is a plastic, or a rubber, can say that. And the center is a conductor, a copper conductor. So I believe you have understood the three types of cable, which is cat cable, fiber optic cables, and the coaxial cables. Okay, so let's see what we have next. Wow, that's the end of today's class. Let's meet in the next class. Thank you. Bye.